Solving a system of equations by elimination is a pretty nifty technique. I find that students tend to like to use elimination more than graphing or substitution, but graphing and substitution are also very important methods to understand. Here we're going to have a couple examples of elimination that might be a little different than what you've seen before. So in this case, with our 2x minus 3y equals 11 and x minus 5y equals 2, let's just go ahead and try to add the equations and see what happens. We add these equations. 2x plus x is 3x. Negative 3y plus negative 5y is negative 8y. 11 and 2, that's 13. This doesn't seem to be doing much. All right, maybe I've got to subtract. 2x minus 3y equals 11. X minus 5y equals 2. Subtract. Okay, 2x minus x, that's x. Negative 3y minus negative 5y is positive 2y. 11 minus 2 is 9. This is not getting us anywhere. You may notice that the issue here is I don't have coefficients that are the same for x or the same for y. So if I don't have coefficients that are the same, I can't subtract. If I don't have coefficients that are opposites, I won't be able to add. So let's try something else with this. All right, 2x minus 3y equals 11. X minus 5y equals 2. Now, if this x had a coefficient of 1, or excuse me, not 1, but had a coefficient of 2, then I could do 2x minus 2x. So maybe I can do something and get a 2 here. If I multiply this whole equation by 2, that will give me 2x minus 10y equals 4. So now I can subtract this equation from that first equation. 2x minus 2x. The x's are eliminated. Negative 3y minus negative 10y. Be careful with the double negative. Negative 3 minus negative 10. 7y. 11 minus 4, that's 7. All right, piece of cake here. Y equals 1. Now I'm just going to continue the way I always continue by using this value in one of the equations to find the other variable. 2x minus 3 times 1 equals 11. 2x minus 3 equals 11 plus 3 plus 3. 2x equals 14. Divide by 2. X equals 7. So it looks like the solution is 7, 1. Of course, we want to check the solution and be sure that we are correct. We're going to take the ordered pair, use it in both of the original equations. Just in case we made some error here by multiplying, we want to go back to the original equations, and that would help us catch an error. 2 times 7 minus 3 times 1 is 11. 14 minus 3 equals 11. 11 is 11. And in the second equation, the original form of the second equation, 7 minus 5 times 1 equals 2. 7 minus 5 equals 2. 2 equals 2. That is correct. Terrific. Well, let's try another example. Here we've got 3x minus 4y equals negative 10. 4x plus 5y equals negative 3. Fascinating. I don't have coefficients of x that match up. I don't have coefficients of y that match up. And I don't have some easy way to multiply 3 so it'll match up with 4, or multiply 4 so it'll match up with 5. I could use fractions and decimals, but then it gets kind of messy, especially on the right side of the equation. But if I start to think about least common multiple, I can then get a coefficient of x that will be either the same or opposite, coefficient of y that would be the same or opposite. Consider if I multiply the first equation by 4 and the second equation by 3, I would have 12x and 12x. If I multiplied the first equation by 5 and the second equation by 4, I would have negative 20y and positive 20y. So I'm going to do something along those lines. I'm going to multiply the first equation by 4. I'm going to multiply the second equation by not just 3, but negative 3. That way it will become an addition situation, and I won't have to worry about the double negatives. This first equation becomes 12x minus 16y equals negative 40. The second equation is negative 12x minus 15y equals positive 9. Now I have addition. 12x plus negative 12x, eliminated. Negative 16y minus 15y, negative 31y, negative 40 plus 9, negative 31. Oh, wow, that's so convenient. Divide both sides by negative 31, y equals 1. Now I rewind and go back to the original equations to use my value of y so I can find x. We always go back to the original equations just in case we made some error converting the equations when we multiplied. 3x minus 4 times 1 equals negative 10. 3x minus 4 equals negative 10. Add 4. Add 4. 3x equals negative 6. Divide by 3. Divide by 3. X equals negative 2. That's good. Looks like my solution is negative 2 comma 1. And yes, we are going to check in both equations. The original form of the equations. 3 times negative 2 minus 4 times 1 equals negative 10. Negative 6 minus 4 equals negative 10. Negative 10 equals negative 10. That works. And the second equation, yeah, 4 times negative 2 plus 5 times 1 equals negative 3. Negative 8 plus 5 equals negative 3. Negative 3 does, in fact, equal negative 3. So negative 2 comma 1 works in both of these equations. When we use elimination to solve a system of equations, to find that ordered pair that will work in both equations, we will need coefficients of x that are either the same or opposites, or we will need coefficients of y that are either the same or opposites. If we have those in the equations already, we can just straightforward add or subtract, but if we don't, we will usually end up having to multiply one, sometimes both equations, so we can get a new equation where the coefficients will match up, allowing us to eliminate the x terms or the y terms.